Hello and welcome to the channel, and if this is the first time you're viewing, please like and subscribe. I do appreciate it, and for those returning, thank you again. So today's video, like I said from the last video, is going to be about DHCP servers. And DHCP, what it is basically it's a dynamic host configuration protocol. It allows IP managers to provide IP address quick and easily without necessarily configuring the client devices any further than just turning on DHCP on the client device. So without further ado, let's get started. So today I'm going to use more devices than I used last time. So we're going to start with two different routers. They'll be serving as my two different networks, and we're going to need two switches to have the devices to connect to, and let's have a few PCs. Let's have a few here too. Let's do 4 each. A few laptops. And a server in each. Well, let's throw a printer in there too. Perfect. Now, if I had given you, let's say, 20 minutes to get all these devices connected to the network, if you were doing it based on my last video, it would take you a while because you would have to remember the IP address that you already handed out to not give it out to the next device. In this small environment, it's easily manageable, but in a very large enterprise environment, IP address assignment is very crucial, because if you provide the same IP address to two separate devices, it will cause communication issue, not allowing that device to communicate outside the network or even within the network while the other device is communicating. So DHCP handles all of the management and device configuration, such as the network side and everything. So to get started, let's start with our crossover cables to connect our devices. We're going to do the same thing here. And we'll also connect the routers together. So let's cancel here. And now let's also connect our devices to our switch. Perfect. And for our servers, I'm going to leave them. I'm still going to connect them, but I will show you how to still configure them static IP wise in this environment. The reason I'm showing that is because when you have an environment such as enterprise environment where you have a dedicated server that is providing a service to your network, you don't want that IP to change. You want your client devices to be able to reach that device at its set IP address, just for network cleanliness, because that device is also going to be connected to the network at all times, so there's no need for it to not have the same IP address. So now all the devices are connected to the switch. While they are connected to the switch, they're still not able to communicate with each other because they have not been configured. So let's start first with our network topology. So basically, I'll set what I'm going to be doing. So this we'll name this network A, and let's also set the IP address you're going to use. Not set it, but basically write it down, so we have a visual aid of it. And the router is going to be 10.0.0.1. And now let's set up the other side. This will be network B. And network B is going to follow almost the same schematic. It's just the only thing different is going to be the IP address. We're going to have a 1 here and 0/24. And this router is going to feature up. Okay, and this router is going to feature the IP addresses 1. Perfect. Now let's go ahead and turn on the ports. And go here also. Turn them on. Turn them on. So now let's go ahead and set our IP that we're going to use for network A. 1.0. And we're not going to use that subnet mask because we already defined it. .0. Oh. Because I set the so 0.1. Okay, let's go here, 10.0.0. 255.255.0. Perfect. Now we have our network configured to communicate. So the device that we're going to use as static, we could connect them now, but I also want to continue with the server DHCP server configuration. Then I'll show exactly where I'll just reserve IP addresses for those devices also before prior to configuration. So let's exit out of that, and we're going to we're in network A, so let's do IP DHCP pool network A, and we're going to network. Now we're basically telling the router what the how big the size of the network is going to be. So it's going to start from 10.0.0.0, and the subnet mask is 255.255.2.0. Boom, and the default router address is 10.0.0.1, and our DNS server that we're going to use is always Google. Not always, but that's the preferred one. And we're also going to exclude some IP to reserve for static usage. So DHCP excluded addresses going to be 10.0.0.1 and to 10.0.0.15. So we were reserving the first 14 IP addresses because the first one is already reserved for the router, so it can't be reused again. Oh, my throat's getting a little dry. Perfect. Let's continue. Go ahead and hit enter. And we'll go ahead and do the same thing on the other side. So config, exit, and we'll go IP DHCP pool. Too many spaces. DHCP. And network. 10.0.2.0 255.255.255.0, and our default router is at 10.0.2.1. DNS server, and DNS server, what it is just a domain names resolver. So basically when you reach out to google.com or facebook.com, youtube.com, their actual servers are not named youtube.com. It's just the named resolver that it is given and registered as, but physically they have an IP address, and your network is communicating with their IP address to reach that. But because there's a domain name resolver, because it's easier for people to remember instead of numbers, so that's how you're able to reach google.com, youtube.com via letters. So, and we're also going to do the same IP DHCP exclusion here. Excluded address. I can't type today. It's going to be 10.0.2.1 till 10.0.2.15. Boom. Perfect. Now, this network and this network is configured to work with DHCP. So all we have to do is go to the actual devices, configure them to use DHCP. Perfect. And we could also see this in real time. So let me go ahead and close that window. So and we should be able to see an IP address. Perfect. It's working. There we go. So let's go ahead and go to each of those devices. Turn them on. For the the server, I'll leave it as static because I already have IP address that I could hand out to it. So if I was hosting a service, it could be such as a mail server. That would be a static IP address that is always the same. It doesn't change in our network and is reserved for specifically for that. So let's go ahead. The last one here. And for this one, let's go ahead and go to config. No, desktop IP configuration. It's already in static. That's 0.2 since it's on the chain. And the subnet mask is 255.255.0. Our router IP address is 10.0.0.1. And our DNS server is this. Perfect. Now let's go to the second one and configure this one also. So this one is 10.0.2.2. And we are going to change this to 255.255.0. And our default IP address for our router is 10.0.2.1. DNS server is 8.8.8.8. Perfect. Now, all of these devices are configured to communicate within their own network. So if I were to take a message from here to send here, successful, and the same thing here, successful. So if you know exactly what's happening, let me go ahead and delete this. Send a message from here to this server. And boom, receives it. It's going to send an acknowledgement and successful. Perfect. And the same thing will happen on the other side. So let's close this one to make it quicker. And boom. Now, if I were to take a package from this network to this network, it will fail. The reason being, this network, although this router is connected to this router, they're not even set to communicate with each other yet. There's no routing set between them. So to have both departments to communicate with each other, what we'll need to do first, create another network. So we'll name this network C. And network C will feature the IP address of 10.10.10.0/8. And for this network, this device will also have its own IP address to be able to communicate within this network. So it's going to be 10.10.10. Add an extra period in there. And we're going to give this one to 1. Let's give this one 10.0.10.10.10. 0.2. Let's move this here so it could be a little cleaner. Perfect. Now we need to go inside the routers themselves and in the interface that they're connected to, set those IPs as such. 10.10.1, and the subnet mask we're using is 0.0.0. Okay, we'll go ahead and do the same thing here. 10.10.10.2. Okay, and now let's go ahead and do some magic. Although these routers are able to communicate with each other, they're not able to, let's see, on. These routers are able to communicate with each other, but they're not able, the network themselves are not able to see each other. So these devices, they're within the same network, but these devices themselves are not. So the way to resolve this, just double check something here, making sure my IP addresses are configured properly. Perfect. So the way to do this, we have to go to the routing table and create routes. Basically tell the IP address where to find this network. So if we want to reach the network of 10.0.2.0 with the subnet mask of 255.255.255.0, we first need to go to this hop, which is 10.10.10.2. Let's add it to this one, and we'll go ahead and do the same thing on the other side. Let's go to router 2, static, and we want to reach network 10.0.0.2. And I mean that's 0, and then we the subnet mask of 255.255.255.0, and the next hop is going to be to 10.0.0.2. Perfect. Alright, so now let's test it out. I'm getting a failed, so let me double check something here. To reach this network. Oh, that doesn't even exist. Why did I type that? At 10, let me remove this first. So we're in router A. We're trying to reach router, so we're going to go to this network, .0. 255.255.255.0. The next hop is 10.0. No, our next hop is 10.10.2. Did I not type that before? Oh, no. 10.0.0.0 with the subnet mask of 255.255.255.0. Our next hop is this network. So basically, if we're in network B, we want to reach network A, we first need to reach network C to go to network A. So that's what we're telling you. So before I headed to reach network B, you first need to go to reach network A, you first need to go to network B to reach network B. It was weird. So 10.10.10.1. Now, let me remove these. We're cooking with fire, cooking with fire, cooking with. I'm in network A. I'm reaching 0 via 10.10.2, yeah. And I'm here reaching 10.10.0 via 10. Yeah, why they failed? I want to see where it's failing, so we'll see together. Okay, let's. All right, let's go. Perfect. So it should be going to this side. Yeah, so why did it fail earlier? I'm telling you, sometimes you just gotta try and see. And boom, we should get a successful, because right now it's crossing over and it should bounce back to the other network. And I should get a success. And boom, perfect. Now we know our network is our network is set up to communicate with then this network, but also can reach devices across this network, and both networks are able to communicate simultaneously. So next, the video suggestion, just put in the comment, and thank you for stopping by. Have a wonderful day.